If you have ever been intrigued by the mysteries of the quantum realm, the behavior of subatomic particles and the fundamental forces that govern our universe, then you are in the right place. Today's video is all about equipping you with the essential tools to kickstart your exploration of this fascinating realm. But wait, what is our secret weapon in this quest of knowledge? Books. Yes, books are our trusted companions on this journey into the depths of the quantum mechanics, particle physics, and beyond. Today I will be sharing with you a selection of books that I believe are absolute must-haves for anyone looking to explore these topics. These books are not only informative but also written in a fashion that is very friendly for any beginner. My name is Shaunak and you are watching this video on my channel Physics for Students. Welcome to the third episode where we are exploring how to learn quantum field theory, and this video will be essentially dedicated into learning methods and what are the best books. So first let us understand that why these books are important. Now you see, these books are like portals to the minds of brilliant physicists and scientists who have really spent years and years unraveling the mysteries of the universe. They contain the distilled wisdom of generations, the key to understand the building blocks of reality and the gateway to grasping the most profound concepts in science. So number one, these are the best books for beginners in quantum mechanics, particle physics, and the ancillary areas of quantum field theory. These books will serve not only as a book, but I would say as a mentor or your guide or your companion on this incredible journey. And whether if you are a complete newcomer or you have already started learning the subject of quantum field theory, or if you're looking to deepen your understanding what you have already learned, then these books are tailor-made and this will cater to your needs. So having said this, that these are the most important factors and that is why we need the books. First, I would like to give you a quick review of those who have missed my first and second episodes on learning quantum field theory, just quickly so that you won't miss on the important concepts. So here you see I'm showing you the thumbnail, part 1 and part 2, how to learn quantum field theory. It is there in my channel Physics for Students. You can just quickly go. As you can see, these are almost more than 40 minutes because I have divided these into blocks and then sub blocks and then the mathematics, then the physics, what are the books, what is the sequence, so you can go ahead with that. First is that what we have learned earlier is this one. We have learned that why do we need Lagrangian and Hamiltonian mechanics, and we have said that in quantum field theory Lagrangian density actually plays a important role because from particles we are moving into fields, and this field theory actually extends Lagrangian to Lagrangian densities. Right below you, as you can see, this is the Lagrangian equation, which is further have been used double integration in order to sum up the densities. So how Lagrangian density is related to quantum field theory, it is there in my second video which you can watch, but this is the basic summation that the Lagrangian density measures the distribution of the Lagrangian space of the Lagrangian over the Lagrangian space. So if you want to know more about that, go to the second video which contains these details. We have also looked into what is called symmetry and Noether's theorem, and we have seen that these are used to simplify the equations of motion, to classify different types of particles, and Noether's theorem is actually a very significant contribution and it is used in many ways to relate with the symmetries of quantum field theory. We have also seen that symmetries provide a framework in order to understand how physical quantities actually behave and transform. And what are the symmetries? We have earlier looked into it, so I won't go into much details. We have seen what are continuous symmetries, translation, rotational and Lorentz symmetries, discrete symmetries. We have seen internal symmetries including isospin, flavor and chirality. We have seen the famous SUSI, that is the symmetry relationship between fermions and bosons, and we have also seen what is called a conformal symmetry. Now very recently I have made a video on what is called the Noether's theorem, and I think that if you go ahead and check onto it, then you will find much more details about Noether's theorem only yesterday I have launched that video. It contains the details of Noether's theorem, each and every symmetries, and not only how Noether's theorem actually saved Einstein, David Hilbert and Felix Klein from general relativity, which seemed to be violating the law of conservation of energy. So this is one of the most beautiful, I would say, theorem in physics. So if you're really interested other than quantum field theory, here is the video, Noether's theorem unveiling the hidden symmetry of the universe. You can go ahead and check it. We have also dealt with Hamilton's equations and Poisson brackets, which is actually a transition, what we call from classical field theory to quantum field theory, and I have described in details what are Poisson brackets. So these are again in the second part of the video, and you can go ahead and find it out. Classical fields to quantum field operators, what are the things, and most importantly Dirac's canonization equation, that is called quantization, or I would say canonical quantization. We have also looked into why do we need to understand this book, that is our special relativity, taking into consideration Maxwell's equation, because relativistic Maxwell's equations are the stepping stone for the quantum field theory. I have also given an understanding of this wonderful book by Daniel Fleisch and Laura Kinman, which is called A Student's Guide to Waves, and these are the basics, because quantum mechanics and further quantum field theory is based on wave mechanics. So until you know what are waves, wave equation, wave components, electromagnetic wave, it won't be possible, and this is one of the best book that I would suggest. Also, I have spoken a lot about this book, which is called Schrödinger equation by Daniel A. Fleisch, and this gives a detailed understanding of Schrödinger equation, and most importantly this book assumes nothing and builds up right from the basics, including vector functions, Dirac notation, eigenfunction, projection operators, and so on. So these are the books which we have talked in details, and most importantly there are certain books on Fourier transform. So these are the 4 books which I have suggested out of that. This is the first book you need to read, this is the second, this is the third, and the fourth. However, all these books, 4 books of Fourier transform are equally important, but if you go it sequentially, I think it will be very easier. Lagrangian and Hamiltonian, utmost important. This book of Patrick Hamill is very important in terms of Lagrangian Hamiltonians, and I have given quite a number of details about Lagrangian Hamiltonian. This would be a very good book to read with. Now, apart from this, what we need to understand is that when we go further into learning quantum field theory, what is important is quantum mechanics. So at the core of framework of the principles of quantum field theory is quantum mechanics. We can call it as like the Rosetta Stone of the universe, allowing us to decipher the language of particles and forces. Now, out of the many books, innumerable books of quantum mechanics which are available online, lecture notes, hard copy books, I have listed down few of the books which are very important. Now, before going ahead dealing with the books of quantum mechanics, I would like to tell you that what are the concepts of quantum mechanics which you specially need to emphasize and learn, because you are keeping into mind the long-term target, that is learning quantum field theory. So these are the things which you are learning quantum mechanics as a whole in the course, but these are the concepts which you must learn with much more emphasis. First is the wave-particle duality, obviously, because this is the basic paradigm shift in terms of mental and fundamental mathematics, that electrons and photons behave both wave-like and particle-like behavior. This is important, quantization of energy, because this is again a fundamental stepping stone from the continuous. Now we move into quantization of energy. You also need to learn about what is called wave function and probability, and better to do a lot of mathematics into calculating wave functions using the Bra and Ket notation and the probability part. This is again important, operators and observables, because in the last quantum field theory part 2, I have shown you that what is called canonical quantization is that the basic observables of the classical mechanics are now being replaced by operators in quantum mechanics. So this is also important. I think I don't need to explain this famous principle, Heisenberg's uncertainty principle. I would recommend go back to one of my videos where I have taken a deep dive into understanding Heisenberg's principle from Fourier transform, and what are the similarities, and why you should understand Fourier transform in order to understand Heisenberg's uncertainty principle. The both time dependent and time independent equation equations of Schrodinger equation. This is important. You can refer to the earlier book which speaks very easily about Schrodinger equation. Quantum states and Hilbert space, well, this is something a little bit more mathematical. You can go back to my video on the mathematics of quantum mechanics, which I would take 3-4 more videos to complete the entire playlist. You need to learn a lot about angular momenta because the angular momentum operators are dependent on this. Identical particles and quantum statistics. This is also important, including the addition of angular momenta and angular operators. You also need to learn a little bit about quantum mechanics, the spin, how the particles behave, the spin of the particles, etc., and the approximation methods. Approximation methods are important because in perturbation theory, especially in quantum mechanics, what we do is that we give a lot of emphasis on approximation methods. So these are the concepts, I would say. Apart from the entire understanding of quantum mechanics, I would suggest strongly that these concepts should be read, understood. You can do a lot of examples on that because based on this you are again moving into quantum field theory. Coming back, what are the best books of quantum mechanics? First of all, I would like to recommend Leonard Suskind's Quantum Mechanics, the Theoretical Minimum. This is an absolutely amazing book, and I can tell you with a lot of responsibility that if you go through the entire book, you really don't need any other book to read. But however, different books give different kinds of details, so it is better to consult more than one book. So you can see already it is 66%, which is showing customer review in Amazon, which has got a 5-star. Now this book, if I go for the basic content part, so these are divided into 10 lectures starting from systems and experiments. Now why I am telling that this book is the ultimate book and really you do not need any other book, I will soon justify. So you see the first lecture starts with systems and experiments, which a very less number of book actually shows you that what are the system and what are the experiments, and these experiments results produce something which we called counterintuitive, and things starts to mature. So it starts with spins and qubits, and you can see there are nice diagrams using single die, how the spaces of states, and this is absolutely amazing. Most importantly, Professor Leonard Susskind, what he has done is that in between, if you need a mathematics, he has included that. Mathematical interlude like complex numbers, then there are functions, vector spaces, everything. Whatever you need that you don't know the mathematics, in between he will take a pause and go ahead. Bras and Ketz, inner products, etc. Lecture 2 starts with different kind of quantum states, including state vectors, spin states, column vectors, absolutely written easily, anyone can understand. Again, a mathematical interlude because you need to know the machine matrices, the eigenvalues, eigenvectors, Hermitian conjugation. So wherever you need it, there is a pause and he is going back, making you understand the mathematics and going ahead with the lecture. So you see the Gram-Schmidt procedure, constructing spin operators and spin polarization principle. The lecture 4 starts with time and change, which includes unitarity, the Hamiltonian, what has happened to h bar, that is the reduced Planck's constant, the conservation of energy, the collapse of the wave function. Lecture 5 starts with uncertainty and time dependence. I'm not going too much because it is a 350 plus pages book. The entire video will be consuming this time. So it does. Lecture 7 is on combining system, more on entanglement, particles and waves. Lecture 9 specifies on particle dynamics, which starts with non-relativistic free particles and then the time-independent Schrodinger equations. It deals much more details in what is called a quantization, gives several other examples which would be absolutely great if you read it. Lecture 10 starts with the harmonic oscillator, classical description, quantum mechanical description and the Schrodinger equation. So even you can see the appendix, it is such beautifully organized, the Pauli matrices, the change of bases, action of spin operators, even the table that he has used, that is the spin operator, different types of operators using different eigenvectors, all these things are included. So what I can tell you at the end is that this is an absolutely best explained. The math part is clear, very simple, lucid, gives a very deep insight and it is very easy to understand. So classical and quantum, the difference is very clearly and deeply philosophically laid out. What is a system, experiments, results of experiments, spins, and vector spaces. So all the mathematics is included, the physics is included, and wherever you need to go back and understand the mathematics, he has taken an interlude kind of a thing and he has gone back and he have made it clear. The second book I would recommend is very good for beginners, that is A.C. Phillips' Introduction to Quantum Mechanics. Already you can see 66% votes for a 5-star, and I would like to show you quickly the table of contents. So you see it starts with Planck's constant in action. Then it goes to Schrödinger equation and very easily described. I mean to say, if you read this book, you will understand position and momentum, energy and time, and then it goes into square wave, that is the quantum barriers, harmonic oscillator. Further, the books also lucidly explains what are called observables and operators, angular momentum, and he takes the example of a hydrogen atom, which is relatively easy to expand on the mathematics. He uses the relativistic part, identical particles, atoms, and so on. So what I can tell you in a nutshell is that this book clearly describes various mathematical relationships. It is absolutely easy to understand. These books require just a little bit of knowledge of calculus and the classical physics that you need to know, and it explains clearly with appropriate amount of maths. That means not much of mathematics is concerned, not less of mathematics is concerned. It is absolutely appropriate, and the quality of writing is basically to encourage and stimulate the undergraduate student encountering these topics for the first time. So if you are an undergraduate student, if you are encountering it for the first time, then this book would be absolutely an amazing book for you. So this would be a second recommendation, A.C. Phillips' Introduction to Quantum Mechanics. Now this book is absolutely great. I mean to say, this is by a great person called R. Shankar. I think everybody knows about Professor R. Shankar. This has already got a 74% rating of 5-star. Principles of Quantum Mechanics. Although the book seems to be a little bit more mathematical, but this book starts right from the beginning, and it shapes in a very nice way. Let me show you table of contents of this book. So you see it starts with the mathematical introduction, which is again quite beautiful. It starts with subspaces, linear operators, eigenvalue, linear vector spaces, everything. Then it reviews the classical mechanics. You see how Professor Shankar beautifully has done that. He is reviewing the classical mechanics, that is the Lagrangian, the electromagnetic Lagrangian, the Hamiltonian formalism, etc. Why Professor Shankar is reviewing? Because it is always better to first review over the classical mechanics and then jump into the modern mathematics and physics of quantum mechanics. Then he writes this, all is not well with classical mechanics. Obviously all is not well, because the double slit experiment actually shows the wave particle duality. Then he starts with the postulates. The postulates, discussion of postulates 1, 2 and 3. Again, it is very systematic, because without understanding mathematics, without reviewing the classical mechanics, without understanding the limitation, and without the basic principle, that is the postulates, how can you go into quantum mechanics? Then he takes up into a simple problem in one dimension, the classical limit, the harmonic oscillator, the path integral formation of quantum theory, and so on. So what I wanted to tell you is that you see that the way the book has been organized shows that this book will be just amazing. Symmetries and their consequences are defined. Hydrogen atom, again the eigenvalue problem, spin. So more or less, if you see the books by great authors and professors, the organization itself depicts that the book will be fine. He then goes into time-dependent perturbation theory, scattering theory, Dirac equation, the path integrals part 2, that is the spin and the fermion path integrals, and then he finally puts a conclusion with the appendices. So this is also a great book by R. Shankar. If you just follow line by line, chapter by chapter, without skipping any part of it, I think you are done. You are done with quantum mechanics, because you know the basics, the mathematics, the limitation, the postulates, and then you go into the physics. So I think that would be great. So my review would be that this level of is more mathematical, and it tackles things much better than Griffith's book, right? And it provides a strong mathematical formulation, which I was telling, that with a review of the intermediate classical mechanics, including Lagrangian, Hamiltonian, etc. And it contains 2 big chapters, remember. One is the mathematical method, and then the classical mechanics, which basically makes the foundation very strong before you go into quantum mechanics. It also, I would say, the author discusses the path integral and symmetries early on before getting into hydrogen atom, because other books I have seen that they leave the path integral much later. But this is good that you learn the path integral symmetries earlier and then go into the hydrogen atom approximation. And this way of introducing path integral is much better, because introducing path integral demystifies some of the mysteries, and when they are represented near the end of the book, you have already done with that. Also, introducing symmetries helps to keep your mind at the back, because these are basically the core concepts and the heart of the physics lies in that. Okay, I think this book requires no introduction. That is called Feynman Lectures on Physics. 88% has given a 5-star, and the good part is that this book is already available online. I mean to say the lecture notes is online, so I have given it in block, feynmanlectures.caltech.edu, so you can just go to Caltech's website and you can just read, download, and whatever you want to do with Feynman Lectures. It is all free and clear with 1, 2, 3 and further volumes. So all the physics starting from classical mechanics to classical mechanics is given. Now that we have done with the quantum mechanics, obviously we have to first start dealing with what we call the first book to start with quantum field theory. And to your surprise, this book is not about directly quantum field theory, but this is what we call Franz Gross relativistic quantum mechanics and field theory. Obviously, relativistic quantum mechanics means quantum field theory, but this book again builds up on the quantum mechanics, uses the relativistic equations, and then goes into field theory. So here is the kind of a review as an experiment. I find this is very approachable. Few people say must have, 4 stars, excellent book, excellent discussion on all the topics. If you really want to know about Professor Franz Gross, you can go to this website, and he is an emeritus professor of physics at the College of William and Mary, and you can just read about it. I always feel that before learning the book or before going ahead with the book, it is important to know who is the author, so that the credentials and the style of reading is also being concerned. So Franz Gross relativistic quantum mechanics, it starts with the quantum theory of radiation, quantization and non-relativistic string. Then it goes into electromagnetic field, interaction of radiation. Most importantly, part 2 starts with the Klein-Gordon equation, which is the first step in order for the unification. So you see, he has done the 2-component form, non-relativistic limit. Then you have dealt with the Dirac equation, which contains the Coulomb scattering, negative energy states, application of the Dirac equation, and so on. Further, I could say that this is, it also contains second quantization, which is very important. The Noether's theorem, as I was telling, that you need to learn Noether's theorem, that relativistic decays, introduction to Feynman rules, loops and introduction of renormalization, vacuum polarization, everything. I mean to say, the relativistic part of quantum field, quantum mechanics, whatever the topics, whatever the things are required, it is included in this book. Finally, he concludes with this path integral, then renormalization, and then the appendix, which includes vector and tensor, Dirac matrices, and Dirac spinors. Now, my take of this book would be, initially this book looks very highly mathematical and some readers might find it difficult. But the important part is that you see that most of the quantum field theory books, when they're trying to explain, Feynman diagram, they introduces basically, the single, the two fermions part. But here, as the primary example for introducing Feynman diagram, Professor Gross introduced the single scalar particles instead of 2 fermions. So what happens? Things becomes much easier. The second quantization, the Fock spaces, etc., are very much clearly covered up. So there is absolutely no problem on that. So we now come to what we call that, what other than the things required, we have understood quantum physics, we have understood the mathematics. The one thing which is lacking, which is called a basic idea and introduction to particle physics, because quantum mechanics and even quantum field theory is all about particles, their interaction. So basic knowledge and introductory knowledge of particle physics is something which is required, and I would recommend this book, Quarks and Leptons, which is an introductory course of modern particle physics by Francis Halzen and Alan D. Martin. This has got a kind of a rating of 65% of 5-star, but this is just an amazing book. Let me show you the table of contents. Before that, here is a quick review of those. This is a rigorous introductory book in particle physics. Overall, this is an excellent book. Some says this book gives a precise and to the point explanation of the particle physics concept. Nice book, very good introductory physics. So more or less what you can see that from these snapshots, that this is a very good book in terms of understanding the basics of particle physics. So let us see what are the table of contents. Before that, the book is written in this way: introductory material, quarks, QED, then the partons, then the QCD. So it is a kind of a schematic diagram which overall gives an idea how the book is organized. So you see, it starts first with a preview of particle physics, quarks, color, I mean to say basic things. Then it starts with gravity, the particle detector. So you get a basic idea that what the particle physics and what it is all about. So you can get a fair kind of an idea. Then it starts with symmetries and quarks, symmetries in physics. What are symmetries in physics as a whole? We go to the next page, which shows quarks, atoms, antiparticles, which includes again the Klein-Gordon equation, the electrodynamics of spinless particles. It is good point to start with spinless particles, so that with spin particles the chirality etc. becomes too much complex. So it starts with the decay rate, electron-positron scattering, invariant variables, and so on. And you can see that electrodynamics of spin particles concerning photons, polarizations, vectors, photon propagator, real and virtual photons, Compton scattering, pair annihilation, everything. Whatever it is concerned related, what you need to know about particle physics, not going into too much details, but at least explaining the basic concept part, that is already done. The structure of hadrons, including the probing E-charge distribution, then the partons, which includes the quarks within the proton, and a part of quantum chromodynamics, although again it's a very complex and a lot of mathematics required, but it covers comprehensively what is called the quantum chromodynamics. Then it starts with the annihilator and the constructive operators, weak interaction, pion decay, muon decay. These things are already being covered. And then it starts with gauge symmetries. Again, Noether's theorem, symmetries and conservation. Weinberg-Abdus Salam model. This is again very important. What we called is that it is an electroweak theory. So all these things are being covered. So my review for this book, quarks and leptons, would be great. These are few of the diagrams. You see, these are beautiful diagrams, because particle physics is all about diagrams, the annihilation, particles coming in. So these are the few of the diagrams which explains things quite clearly. So my take would be, it is a very good book as far as the introduction of particle physics is concerned. It gives you a complete overview of the related areas of particle physics without going into details, and these books would give a complete understanding of the particles, their interaction, how they come in, they annihilate and other areas. And there are a lot of exercises which are given at each end of the chapter, so that you can do it if you like, so that the foundation is much more important. So this actually concludes our discussion on the third part of our video of learning quantum field theory, where the concepts of quantum mechanics, the books of quantum mechanics, the books of particle physics, and what are the books, because I spent a little bit more time in explaining quantum mechanics, because as I told, this is the Rosetta Stone of starting quantum field theory, and the other parts are also being covered. So thank you very much for watching this video. If you have liked it, please do not forget to hit on the subscribe button and click on the bell icon to get all the notification from Physics for Students. You can write to me at this email ID, and this is my other channel on general theory of relativity. And if you want, you can further follow me on my Facebook, LinkedIn, Instagram, and Twitter account. I will be waiting for your comments, how this series is going on, and then we will start learning the real part of quantum field theory with a series of lectures. Thank you very much for watching the video. Please put up your comments and wait. I will be coming up few more videos on quantum field theory, and these will be quite intriguing and interesting. Till then, goodbye, and may the good Lord be with you.